Okay, so 6-period video, 369, multiples of 3. This is the easy one for me to keep up with which number I'm on, because it's always just the multiples of 3. Okay, so 1, 2, no thank you. Let's do number 3. The graph of f consisting of 2 line segments is shown on the right. Let g be the function given by g of x equals 2x plus 1. Let h be the function given by f of g of x. What is h prime of 1? Okay, it jumps. I guess is what happens when you start with number 3. So I need the derivative of h. I'm not going to plug 2x into f because I don't really even have f. F is just this picture over here. So instead, I think I'll take a derivative of how it fits right there. Which means let's start with f. Right, outside in, so f prime. Leave the inside stuff alone. So f prime of g of x. And then multiply, chain on the next derivative, so g prime. Leave the inside stuff alone. And I guess if you really want to go next level, you could say we need the derivative of x. But that would just be 1, so that didn't do much for us. So I want h prime of 1. That means wherever x is, 1 goes in place of it. So from here on, it's just, well, I shouldn't say it's just, there's calculus and algebra here. So f prime of g of 1 times g prime of 1. So g of 1, let's see, my picture is f, but I've got an equation with g. So I can figure out what g of 1 is. Plug in 1 for g, or plug for x in g. 2 plus 1 is 3. So g of 1 is 3, so now I need f prime of 3. So f prime, that means the slope of the graph of f at 3. 1, 2, 3. So right there, I need that slope. So that's change in y is -6. Change in x is 3. So that slope is -2. Slope's -2, the derivative's -2. So f prime of 3 is -2 because the slope is -2. G prime, well, I need to go get g prime. So the derivative of g, derivative of 2x is just 2. And so it doesn't matter what the input is, the derivative of g is always 2. And then -2 times 2 would be -4. Man, that was a multi-step deal there. Chain rule, power rule, using a graph to find function values and slope values, composite functions. There's a lot going on for number 3. Number 6. Ooh, a table problem. Table on the right gives values for the differentiable functions f and g and their derivatives at 1. Let's find this thing. Oh, this looks like... What rule does this look like? Product rule, multiplying things. I'm hesitant to label them f and g since f and g are in there. So I'm just going to do first times derivative of the second plus vice versa. How about that? First derivative of the second plus second derivative of the first. So 2 f of x plus 3 times the derivative of the second. Well, derivative of 1 is 0. Derivative of g is g prime. Plus the second, 1 plus g of x. Derivative of the first, so that would be 2f prime. So that's h prime And if I want that at 1, then I need to plug in 1 at all of those places. So f of 1 is 3. G prime at 1. G prime at 1 is 4. Thank you. Yes, he's here. G of 1 is negative 3. And f prime at 1 is negative 2. And then I got to piece all that stuff together. So 2 times 3 is 6, plus 3 is 9. 9 times 4 is 36. Negative 2 times 2 times negative 2 is going to be plus 8. So 44. Goodness, that's a... Another table problem. This time with the quotient rule. Table above gives the values of the twice differentiable functions f and g and their derivatives at 2. If h is this function, what is h prime? Okay, so quotient rule. Normally we say gf prime minus fg prime, but this one's already prime, so let's be careful here. Let's start at the bottom, work our way up, or low d high minus high d low, however you want to think of it. If we start at the bottom, we've got g prime times the derivative of the top. Yeah, gf prime, f prime, minus the top times the derivative of the bottom. Well, what's the derivative of the bottom? Yeah, g double prime all over g prime squared. So quotient rule, but a little bit of a trick since the denominator was already a derivative. So at x equals 2, then we're going to go just find all these things from our table. G prime at 2 is 2. F prime at 2 is negative 3. F at 2 is 4. And G double prime at 2 is negative 5. G prime at 2 is 2, but we square it. So let's see, negative 6 plus 20 over 4 would be 14 over 4, also known as 7/2. And that's one that could mess you up. Been using my stamp a lot today. This one might deserve the calculus is easy, algebra is hard. Hope not, but with all the positives and negatives and tables and simplifying. Number 12. So looking at the picture, as x goes to infinity, positive infinity, so as we head toward infinity, so as we're going out this way, what does it look like f is headed toward? 2. We might not ever get there, but we don't care about getting there. We care about what are we approaching. We're approaching 2. As x approaches 3, well, you can plug it in, but as you might guess, it's not really going to work. So 0 over 0. What do you want to do with this one? Because there are 2 options. Okay, let's soap the top. I like that. X minus 3. Same, opposite. And then always positive. How very convenient. The x minus 3's will cancel, which was the problem. Like 3 minus 3 in the bottom was a problem. So let's now plug in 3 again and see what happens. 3 squared plus 3 times 3 plus 9. I believe that would be 27. There's another way to work that, but we'll come back to that in a moment. Number 18. Before I read anything, I see that it's piecewise, so something's probably going on at 4 that I'm going to have to worry about. What value of k makes f of x continuous? Well, left of 4, it's this parabola, so that's always continuous. That's not a problem. Right of 4, it's this thing, but that would only be a problem at 0, so I'm not worried about that. What I'm worried about is at 4, I need the left limit and the right limit to be the same. So the left limit would be when x is less than 4. So that would be, again, I'm just going to plug in 4 because it's at 4 that we might have the problem. The right limit would be this one, so negative k over 4. And if those are equal to each other, well then it's continuous, so we'd be good. So let's algebra here. 16k minus 4 equals negative k over 4. I think I would multiply through by 4 first, just to clear out that denominator. So 64k minus 16 equals negative k. So 63k equals 16. If I move the, whoops, that's not right. I deserve the stamp for that. Right, I was supposed to add it to the other side. So 65k equals 16. So k equals 16 over 65. I'm going to put the stamp on you. I should put it on myself when deserved. Again, the main thing there was at 4, were they continuous? Are they connected at x equals 4? 21. Find the slope of the line tangent to the graph. Fancy talk for find a derivative when x equals pi over 6. Okay, derivative of tangent is secant squared, which is nice because it pairs with the derivative of cotangent, which is negative cosecant squared. Again, you got to have those 6 trig functions memorized. They're derivatives. You got to know them all. They come in kind of pairs or patterns, so you may not. It's not as bad as it seems. Okay, secant of pi over 6. Let's see. That would be with cosine. So that would be 2 over root 3 squared. Cosecant goes with sine, that'd be a half, but if I flip that, that would be 2 squared. So what that is 4/3 minus 4. 4/3 minus 12/3 is negative 8/3. You can see lots of little algebra on these, and that continues into calculus, and that's why I have the stamp, is because students in calculus get the calculus right and then mess up the stuff before that. 24. G of x equals 3 sine to the 4th of 5x. Oh, this looks like chain rule, chain rule, chain rule. You don't have to rewrite it. I like rewriting it because then it's obvious who the outermost function is. So that's 4. So I'll have 3 times 4, and then all of that stuff to the 3rd. All right, that's how we do the power rule. But we don't mess with the stuff, right? Because we don't eat the blow pop all at once. We go one layer at a time. So on the inside is still sine of 5x. And then the next step down is, or the next layer in, is the sine layer. Derivative of sine is cosine, but leave the argument alone, so it's still cosine of 5x. And then lastly, 5x is in there. That derivative is 5. Okay, so a little bit of cleanup. 3 times 4 times 5 is 60. And 60 with sine cubed and 1 cosine, so B. Chain rule. 27. Oh, that's quotient rule. So, feeling adventurous, I'm not going to label the f and the g. I'm just going to say bottom times derivative of top minus the other way around. So start at the bottom. X to the 6 times derivative of cosine is negative sine minus, and then the other way around, so the top times derivative of the bottom. And I'm going to put 6x to the 5th out front just because it looks better there. All over the bottom squared, so x to the 12th. That does not look like any of my answers, because all my answers have x to the 7th in them. Yes, sir?
Negative 6, or negative x to the 6 is because you brought up the x.
This negative comes from, like I wrote it kind of out of order, but that negative comes from the derivative of cosine is negative sine. There's an x to the 5th in everybody. So let's divide everybody by x to the 5th. That will get us x to the 7th in the bottom. So negative x sine x minus 6 cosine x all over x to the 7th. B and C, only one of the terms is negative, so those are out. D, they're both positive, that's out. A works because the negative is out front. So that means that negative goes to everybody, so yeah, A works. Number 30, another quotient rule problem. This one, though, we're intentionally messing with you, because if all you do is rotely memorize gf prime minus fg prime, you're going to miss this one, because we've switched f and g on you. So the derivative is bottom times derivative of the top, fg prime minus gf prime over f squared. That just feels weird to say and weird to write, because that's not how we memorize the quotient rule. But because f and g are backwards in this formulation, they're backwards in our formula. Okay, then at 2, so now I got to go to the table and find all of those pieces and put them in the right spot. So f at 2 is 3. G prime at 2 is 1. G at 2 is 6. And then f prime at 2 is negative 4. And then in the bottom, f at 2 is 3, so 3 squared. So I've got 9 on the bottom. In the top, I've got 3 plus 24. 27 divided by 9 is 3. The others are similar. 31 would be product rule. 32 is chain rule. 33 is chain rule. Oh, but we can do 33. 33 is chain rule. The derivative of h would be g prime of 2x. That's taking care of the g, but then I need to take care of the 2x. That derivative is 2. So let's So 2g prime of 2x. So h prime of 3, let's be careful here. That means 3 goes in for x. 2g prime of 6, because we plugged in 3. G prime of 6, if I go look, is negative e. So negative 2e. Okay, this is maybe the hardest set of, or the most confusing chunk of the problems is like 35 through 39. So we'll at least hit 2 of them. Which of the following is equivalent to? Okay, so this looks like a limit problem, but it's not really a limit problem, because what is this? That's the derivative of secant. Because that looks like the form of the derivative, f of x plus h minus f of x all over h. So that's the derivative, and it's the derivative of f of x, so it's the derivative of secant, and the derivative of secant is secant tangent. So the answer is E, not really because we did anything with a limit, except recognize that it was the definition of a derivative. By the way, 37 needs a plus sign in there. That way it's f of x plus h. So 37 would be the derivative of tangent at 2 pi over 3. So this one has a specific spot we'd be looking for. 39, it looks like that one we factored earlier, but I don't know how x to the 5th factors, so I'd better leave that alone. So this looks a little bit like f of x minus f of a over x minus a. So it's another one of those, recognize that it's a derivative, don't try to do anything with the limit. So this is the derivative of x squared at, or not x squared, x to the 5th, at x equals 2. So that would be 5x to the 4th, and when x is 2, 2 to the 4th is 16, and 5 times 16 is 80. Again, that one's kind of weird because it looks like we should factor it, but I don't know how that factors, so we have to recognize that it's a derivative. It's the definition of a derivative. It's the alternate form of the definition of a derivative. Right, f prime at a was the limit as x approaches a of f of x minus f of a all over x minus a. So we match things up and realize that it's the derivative of x to the 5th when x is 2. So I feel like those are the trickiest ones. So make sure you're good with 35 through 39. (42) What is the average rate of change? Average rate of change. So that is like algebra slope. So that's f of pi over 2 minus f of 0 over pi over 2 minus 0. So let's find the pieces and see what we get. F of pi over 2 is cosine of pi, and we multiply it by pi over 2 times 2 becomes pi. Cosine of pi is negative 1. Cosine of 0 is 1. So we've ended up with negative 2 over pi over 2. So either keep it, change it, flip it, or you've done it enough where you know what happens when you keep it, change it, flip it. You're going to end up with negative 4 over pi. 45. The figure shows the graph of a function f, that's a weird looking deal, which has a vertical tangent at x equals 2. Ooh, that's important. So at x equals 2, there's a vertical tangent line. What does that mean the derivative is at x equals 2? What's the slope of a vertical line? Yeah, it doesn't exist. So there's no derivative there. Horizontal tangent at x equals 4. What does that mean the derivative is at 4? What's the slope at 4? 0. And then there's a hole at 6, so I better be careful there. There won't be a derivative there either. There's not a function there. Okay, so which of these statements is false? Missed this one on the test because I didn't read the word false. And I picked the first true one, and I was wrong. I mean, my concept was right, but I picked the wrong answer. F is not differentiable at x equals -1. Okay, well, that statement is true because the graph has a jump discontinuity. Yes, it's not differentiable, and it has a jump, so that's a true statement. F is not differentiable at x equals 2. Yeah, we said that already. Because there's a vertical tangent. Yes, both of those things are true. Part C, f is not differentiable at x equals 4. Wait a minute, no, x is differentiable at x equals 4. I mean, this is kind of funny. It does have a horizontal tangent, but that's okay. Horizontal tangent just means that f prime equals 0. So, pretty sure C is false. Let's read the last one just to make sure. F is not differentiable at 6. That's true, because there's a removable discontinuity. Yes, that is correct. So it was answer choice C. And that provides a nice little review of the fancy words: jump discontinuity, vertical tangent, horizontal tangent, removable discontinuity, and in a nice safe place where you can figure out what they all mean. Alright, so that's the multiples of 3. If you need to see other videos, you know where to find them. Good luck.